Welcome back, Algebra 1 students, to Lesson 39. We're going to talk about, it's seemingly trivial and self-evident, but it's important to think about and put on your radar. It's called the Trichotomy Axiom. And the trichotomy, if I can get my pen to actually register all of the letters, the trichotomy axiom actually states that for any two real numbers, a and b, exactly one of the following is true. So a is either greater than b, a is equal to b, or a is less than b. And we call it trichotomy because there's 1, 2, 3 parts to it. So you're going to put that in your notes. Now this helps us to understand negated inequalities. Symbols of inequality can be negated by drawing a slash through the symbol. So we would read this as x is not greater than 10. The not negates the greater than. There are only three possibilities under the trichotomy axiom. So if x is not greater than 10, then it must be less than or equal to 10. So if we see this, we know that the inverse is going to be true. So we can say the same thing by just reversing the symbol, taking the symbol that is not included and putting it between the same two numbers. In the same way, if we write x is greater than or equal to 6, and we negate that, then we're saying x is not greater than or equal to 6. Therefore, x is got to be less than 6. Because we've gotten, we've negated the equal and we've negated the greater than sign, so what remains is the less than. All right, and that's how we can use this to determine the opposite of this. All right, I'm going to erase these samples, and let's do example 39.1. I'll do it in green. All right, so we're going to draw a number line and graph the solution for x is not less than 2. So here's our number line, and here's 0, 1, 2, 3, 4, 1, 2, 3, 4. Right? 1 and 2, negative 1, negative 2. That's all I really need. If x is not less than 2, we have to write the opposite of that in order to graph it. So I'm going to switch to red so we can see the opposite of this would be x is greater than or equal to 2. So in that case, we're going to circle 2 and we're going to fill it in because we have the equal sign, and then we're going to move to the greater side and fill in that line. All right, let's do 39.2. This is really kind of self-explanatory, and I hope that you find it as easy as I do. We have a graph here, and we are going to write both the inequality and the negated inequality that describes this graph. So here we go. We've got this line, and we have 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. And the graph, let me switch to red so you can see it. It circles the number 3, and then it goes on in the left direction. All right, so first of all, we see the the open circle on the 3. So we know that this is not an equal to. So it's not going to be equal to something. So we can write that x is, it's actually less than 3, and it is not equal to 3 because the circle is not filled in. So the negated inequality would be the opposite of this. So we would say x is greater than or less than, and then we would negate that. Right? So first you find what it actually is, and then you write it again and flip the sign, including the other 2 signs, and then put a line through it, and that's how you would negate that. All right. So now that's all we have for the number lines and the trichotomy axiom. So let's move on to advanced ratio problems. I'm going to clear the page, pause and take notes if you need to. Some ratio problems are difficult because key information is hidden by the way the problem is worded. If we are told that the ratio of red marbles to blue marbles is 5-7, we would write red marbles to blue marbles equals 5-7, right? We would get that pretty straightforward. Now, if we are told that we have a total of 156 marbles and are asked for the number of marbles that are red, we would have difficulty because there's no place for the total in the equation we have written. If we use the following 4-step process, we can work any ratio problem with ease because the method will produce 3 useful equations. We write the information given to include the total. So what we're going to do is we're going to go back to our chart and we're going to include the total that I talked about earlier. So we have the ratio, and then we have the actual, and this will be one item, this will be one item, and then the bottom item is our total. And that gives us the opportunity to put in all the information that we are given. So let's start with this first problem. I'm going to pause and write it. All right, so here's our problem. This is 39.3. I'm going to switch to blue. So the ratio of red marbles to blue marbles. So we have red marbles and we have blue marbles. The ratio of red to blue is 5-7. So 5-7. If there are 156 marbles, how many are red? So we have an actual number of 156. And we're looking for the number of red marbles. Now, we can't find that using this ratio. We simply can't. Because they've given us the total, not how many red or how many blue. So what we need to do is find the total for the ratio, and 5 plus 7 is 12. So that's the ratio we're looking for. We don't care about the blue ones right now. So we could just cross a line through there, and now we treat this just like we would our other ratio problem. We put 5 over 12, and then we put an X where we're trying to find the information, and then we put the total. And now we do the same thing we did before, and we cross multiply. So we say that 5 times 156, we're going to put that here, equals 12 times x. And then we're going to divide both sides by 12. All right, which leaves us, when I pull my calculator up, we're going to say 5 times 156 divided by 12 is going to be 65. So we know that we have 65 red marbles. And now we are able to determine that we have, if this is 65, we say 156 minus 65, that's going to equal 1, and that's going to equal 9. So we have 91 blue marbles. Okay, so we're able to find that out just by using this bottom here and just crossing through what we don't need to know so that we don't write this down accidentally. All right, let's try another one of these. I'm going to clear the page. Take notes if you need to. This is 39.4. Let me write this down. And here's our problem. The ratio of fish to crabs in the sea cave was 13 to 4. If there were 119 fish and crabs in the sea cave, how many were fish? So again, we make our chart. We have our ratio. We have our actual. We have our fish. We have our crabs. And we have our total. So the ratio of fish to crabs was 13 to 4. If there were 119 altogether, how many were fish? That's what we need to know. So let's add the two ratios together. We get 17. And so we're not going to worry about the crabs right now. Right now we're going to look at, instead of a question mark, I'm going to put an X here because that's what we're using. So it's easier to match it back up. We've got 13 over, and we go all the way down to total because that's the other place we have information. 13 over 17 equals X over 119. All right, and now we're going to do the same thing we did before. 13 times 119 divided by 17 equals 17 times X divided by 17. Right, so this cancels. So X is equal to, let's pull up our calculator, 13 times 119 divided by 17 equals 91. So there are 91 fish. And now we can find out how many crabs there were. I pull my calculator again. I could say 119 minus 91. There's 28 crabs. So I can fill that information in too, just in case I want it. All right, so that is how we would solve when we are given a ratio and a total, but not any other information to use. So we total the ratio so that these two numbers have a relationship, and when they're placed against each other, our ratio proves true. Right? And if you think about it, 13 out of 17 is the same as X out of the total. So that's how you have to think about it. All right, and that's all I have for lesson 39.4. Not 39.4, lesson 39. I was reading this, obviously, when I said that. I will see you in lesson 40.